Question 4. The battery life of a brand of AA batteries under continuous use is normally distributed with a mean of 5 hours. So we got our mean, 5 hours, and a standard deviation of 1.5 hours. Standard deviation, 1.5. Okay, I'm not going to look at the question. First, I'm going to put that information on our bell curve. Why? Because it is normally distributed. The mean is 5. So from the middle, I'm going to start adding 1.5 going to the right, subtract 1.5 going to the left. So 1.5 plus 5 is going to be 6.5. 1.5 more is going to be 8. 1.5 more will be 9.5. Okay, so that's going that way. Now going back, subtracting 1.5, it's going to give me 3.5. Okay, subtract 1.5 again, it's going to give me 2. Subtract 1.5 again, it's going to be 0.5. And now that we have that information on the bell curve, what we're going to do is just answer the question. All right, if 4,000 batteries are tested, what percentage of the batteries will last between 5 and 8 hours? So let's find 5. There it is. Let's find 8 right here. So what percentage goes between 5 and 8? Well, we find that from our empirical rule. So we can see that between the mean and 2 standard deviations is here and here. So that's 34 and 13.5. Together, that gives me, what was that, 47? 47.5% right there. Okay. Nice. Okay. All right. But that doesn't answer the question. It says what percent. It does say what percent. So what percent is 47.5? But if we want to find out how many batteries there are, if we want to know how many batteries out of the 4,000 fit in that 47.5%, what we do is we take 0.475 and multiply that times 4,000. And that'll give us how many batteries are in that in this range. When I calculate, I get 1,900. So it's 1,900 batteries. And that's our final answer.